Space exploration is humanity's greatest adventure. It is a journey into the unknown, a quest for knowledge, and a testament to our indomitable spirit. Among the many milestones in space exploration, the Apollo missions stand out as a beacon of human ingenuity and courage. The Apollo program, spearheaded by NASA, was a series of space flights that captivated the world. It was a time when humanity dared to dream of reaching for the stars. The ultimate goal, to land humans on the moon and bring them back safely to Earth. These missions were not merely about reaching the lunar surface. They were about pushing the boundaries of human knowledge, developing cutting-edge technology, and inspiring generations to come. The Apollo missions were a defining moment in human history. The Apollo missions were born out of intense competition and geopolitical rivalry. The mid-20th century witnessed the Cold War, a period of tension and mistrust between the United States and the Soviet Union. Both superpowers sought to demonstrate their technological superiority, and space exploration became a key arena for this contest. The launch of Sputnik, the first artificial satellite by the Soviet Union in 1957, ignited the space race. The United States responded with the formation of NASA and the commitment to land a man on the moon before the end of the decade. The Apollo program was the embodiment of this national goal. The path to the moon was fraught with numerous challenges and obstacles. The Apollo missions faced technical difficulties, human limitations, and unforeseen hurdles that tested the resolve of everyone involved. From the tragic fire of Apollo 1, which claimed the lives of 3 brave astronauts during a pre-flight test, to the intricate engineering problems that required innovative solutions, the journey was anything but smooth. Each mission was a high-stakes venture, where the margin for error was slim. Engineers and scientists worked tirelessly to overcome issues like the need for life support systems that could sustain astronauts in the harsh environment of space. They had to ensure the spacecraft could endure the extreme temperatures and vacuum of space while maintaining communication with Earth. Astronauts underwent rigorous physical and mental training to prepare for the unknowns they would face. They had to learn how to operate complex machinery, conduct scientific experiments, and navigate the lunar surface, all while dealing with the isolation and psychological stress of space travel. Despite these daunting challenges, the spirit of innovation and collaboration drove the Apollo missions forward. Every hurdle surmounted brought them one step closer to achieving the dream of landing a human on the moon. The quest to reach the moon necessitated groundbreaking technological advancements that forever altered the landscape of space exploration. The Apollo program spurred the development of cutting-edge technologies, many of which have had lasting impacts beyond space travel. One of the most significant innovations was the Saturn V rocket, an engineering marvel that remains the tallest, heaviest, and most powerful rocket ever brought to operational status. Its development required new materials, advanced propulsion systems, and unprecedented levels of precision in manufacturing and assembly. The Command and Service Module, CSM, and Lunar Module, LM, were also feats of engineering brilliance. The CSM served as the astronauts' home during most of the mission, equipped with life support systems, navigation, and communication tools that were revolutionary at the time. The Lunar Module, on the other hand, was designed to land on the moon's surface and return to lunar orbit, a task that demanded exceptional ingenuity in terms of design and functionality. Furthermore, the Apollo Guidance Computer, AGC, was a pioneering piece of technology, representing one of the earliest uses of integrated circuits. It was capable of performing complex calculations in real time, a necessity for the precise navigation required for lunar missions. This computer laid the groundwork for the development of modern computing technology. The advancements didn't stop at hardware. The missions necessitated the creation of new software systems, including real-time operating systems and sophisticated simulation programs that trained astronauts for every conceivable scenario. These software innovations contributed to the development of the computer science field as we know it today. In addition to these technological strides, the Apollo program also led to advancements in materials, science, telecommunications, and human health monitoring systems. Many of these innovations have found applications in everyday life, from medical devices to improved telecommunications infrastructure. As we look back, it's clear that the technological advancements made during the Apollo missions not only made lunar exploration possible, but also paved the way for future space endeavors. These pioneering technologies have become the bedrock upon which modern space exploration is built, continuing to inspire and drive humanity's quest to explore the cosmos. The journey to the moon was not just a test of technology, but also a testament to human endurance and skill. The training of astronauts for the Apollo missions was an intense and rigorous process, designed to prepare them for the challenges of space travel and the unknowns of lunar exploration. Astronaut candidates underwent a grueling selection process, where only the best of the best made the cut. Once selected, these astronauts faced a comprehensive training regimen that pushed their physical, mental, and technical limits. They trained in high-G centrifuges to simulate the intense forces of launch and re-entry, and underwent underwater exercises to mimic the weightlessness of space. Simulators played a crucial role in astronaut training. These sophisticated machines replicated every aspect of the Apollo spacecraft, allowing astronauts to practice maneuvers, troubleshoot potential problems, and rehearse mission sequences down to the smallest detail. The Lunar Module Simulator in particular was instrumental in preparing astronauts for the delicate task of landing on the moon's surface. Astronauts also received extensive geological training. They studied rock formations and learned how to identify and collect lunar samples that would be invaluable for scientific research. Field trips to volcanic sites on Earth provided hands-on experience with terrain similar to the moon's surface. The psychological aspect of training was equally important. Astronauts practiced teamwork and communication skills essential for the close quarters and high-stress environment of space missions. They participated in survival training, learning how to handle emergencies and adapt to the harsh conditions they might encounter. In addition to these rigorous preparations, astronauts were trained to operate their spacecraft systems and conduct scientific experiments. They learned to navigate using the stars, manage life support systems, and perform spacewalks. Every conceivable scenario was rehearsed, ensuring that astronauts were ready for any challenge they might face. The training was relentless, but it forged a group of astronauts who were not only technically proficient, but also mentally resilient and physically robust. Their dedication and preparation were crucial to the success of the Apollo missions, demonstrating the extraordinary human effort required to reach the stars. As we reflect on the training of these pioneering astronauts, we gain a deeper appreciation for the courage, skill, and determination that fueled humanity's first steps on the moon. The launch sequence of the Apollo missions was a symphony of precision, coordination, and technology, orchestrated to perfection. As the countdown began, the entire world watched with bated breath, knowing that each second brought humanity closer to an unprecedented achievement. The process began hours before liftoff. Engineers and technicians meticulously checked every system, ensuring that the spacecraft and its Saturn V rocket were ready for the journey ahead. Inside the command module, astronauts donned their suits, a final layer of protection against the harsh environment of space. As the countdown clock ticked down, the tension in mission control was palpable. At T-2 hours, the astronauts were secured in their seats, the hatch closed, and the spacecraft sealed. The Saturn V, a towering marvel of engineering, stood poised on the launch pad, its engines primed and ready. At T-1 hour, fuel began to flow into the rocket's tanks, a complex process that required precise timing and control. The final checks of the guidance systems and flight computers were conducted, ensuring that everything was aligned for a successful launch. With 10 minutes remaining, the launch team conducted a final go/no-go poll, confirming that all systems were operational and ready. The atmosphere was electric, a mix of anticipation and nerves. At T-2 minutes, the automatic launch sequence was initiated. The rocket's internal systems took over, executing a series of pre-programmed commands with flawless precision. The Saturn V's engines roared to life, a deafening thunder that could be heard for miles. At T-10 seconds, the final countdown began. The world held its breath. 9, 8, 7, the engines reached full thrust. 6, 5, the hold-down clamps released. 4, 3, the rocket began to rise. 2, 1, liftoff. The Saturn V soared into the sky, a blazing beacon of human ingenuity and ambition. As the rocket ascended, the first stage engines burned with tremendous power, propelling the spacecraft through the atmosphere. At stage separation, the first stage fell away, and the second stage engines ignited, continuing the journey to orbit. The launch sequence was a testament to the countless hours of preparation, the dedication of thousands of people, and the unyielding spirit of exploration. Each successful liftoff was a step closer to the moon, a giant leap for humankind. As we remember the countdown to launch, we are reminded of the incredible teamwork, precision, and courage that made the Apollo missions possible, setting the stage for humanity's greatest adventure. As the Saturn V rocket pierced through the Earth's atmosphere, the astronauts aboard embarked on a voyage unlike any other. The journey to the moon was both a test of human endurance and a marvel of engineering. Once in orbit, the spacecraft performed a series of intricate maneuvers to set itself on a lunar trajectory. The crew experienced weightlessness as they floated inside the command module, a sensation that was both exhilarating and surreal. Outside the windows, the vastness of space stretched out before them, a magnificent void dotted with distant stars. The Earth, now a small blue marble, receded further into the background with each passing hour. As the spacecraft approached the moon, the crew prepared for the critical lunar orbit insertion. This maneuver required precise calculations and flawless execution. The engine fired, slowing the spacecraft enough to be captured by the moon's gravity. The astronauts looked on in awe as the lunar surface came into view, a stark, desolate landscape illuminated by the sun. The journey to the moon was not just a physical expedition, but a profound moment of reflection. The astronauts carried the hopes and dreams of humanity with them, knowing that their mission was a symbol of what we could achieve when we dared to reach for the stars. As they orbited the moon, the crew conducted detailed observations and took photographs, capturing the stark beauty of the lunar surface. Each orbit brought them closer to the moment when they would attempt the historic landing, a culmination of years of preparation, innovation, and unyielding determination. The journey to the moon was a testament to human ingenuity and the spirit of exploration. It was a journey that pushed the boundaries of what was possible and inspired generations to look beyond our planet and into the cosmos. The moment had arrived. After months of rigorous preparation and countless simulations, the Apollo 11 crew was ready to make their descent to the lunar surface. Inside the lunar module, Neil Armstrong and Buzz Aldrin meticulously checked their instruments while Michael Collins remained in orbit aboard the command module, anxiously monitoring their progress. As the lunar module, named Eagle, separated from the command module, the tension was palpable. The descent engine fired, beginning the slow, calculated maneuver towards the moon's surface. The astronauts' voices, calm yet tinged with excitement, crackled through the radio as they communicated with Mission Control in Houston. The Eagle descended steadily, but not without challenges. Alarms sounded, indicating potential issues with the onboard computer. Armstrong, with nerves of steel, took manual control, guiding the lunar module past hazardous boulders and craters. The world held its breath as the spacecraft hovered above the lunar landscape, searching for a safe landing spot. Finally, Armstrong's voice broke through the static. "Houston, Tranquility Base here. The Eagle has landed." A collective sigh of relief and jubilation erupted from Mission Control, echoed by millions around the globe. The lunar module had touched down in the Sea of Tranquility, a flat, serene expanse on the moon's surface. Inside the Eagle, Armstrong and Aldrin prepared to make history. They donned their spacesuits, conducted final checks, and opened the hatch. As Armstrong descended the ladder, his heart raced with the enormity of the moment. He paused briefly, then set foot on the moon, uttering the immortal words, "That's one small step for man, one giant leap for mankind." Aldrin followed, describing the lunar surface as magnificent desolation. Together, they planted the American flag, conducted scientific experiments, and collected samples of lunar rock and soil. Their every move, broadcast live to an enraptured audience back on Earth, symbolized human achievement at its finest. The lunar landing was not just a triumph of technology and engineering, it was a testament to the indomitable spirit of exploration. It was a moment that united humanity in awe and wonder, proving that when we dare to dream, the sky is not the limit, it's just the beginning. As Armstrong and Aldrin concluded their mission on the moon's surface, they returned to the Eagle, leaving behind a plaque that read, Here, men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind. With this historic achievement, the Apollo 11 crew paved the way for future explorers to reach for the stars and beyond. As Neil Armstrong stood at the base of the lunar module's ladder, the world watched with bated breath. Every heartbeat synchronized with his, every eye glued to the grainy black and white footage beamed back to Earth. In that moment, Armstrong was not just an astronaut, he was a symbol of humanity's boundless potential. With a final glance at the desolate yet strangely inviting lunar surface, Armstrong took the last step, leaving the safety of the lunar module and planting his boot firmly into the moon's powdery, uncharted soil. His voice, steady and filled with awe, broke the silence. "That's one small step for man, one giant leap for mankind." As the words echoed across the globe, a wave of emotion surged through every listener. It was a declaration, a promise, and a triumph, all rolled into one. The moon, once a distant beacon of mystery, now bore the first human footprints, a testament to what we can achieve when we dare to dream. Buzz Aldrin soon followed, his steps more assured but no less significant. He described the lunar landscape as magnificent desolation, capturing the stark beauty and profound isolation of their surroundings. Together they moved with deliberate care, each step a calculated dance in the low gravity. The astronauts' activities were meticulously planned, but the spontaneity of human experience could not be scripted. They planted the American flag, its stars and stripes standing proudly against the monochrome backdrop. They conducted scientific experiments, setting up instruments to measure the moon's properties. They collected samples, each rock and soil fragment a piece of the moon to be studied back on Earth. But beyond the scientific objectives, their presence on the moon was a powerful symbol. It was a message to future generations that no frontier is too distant, no challenge too great. Armstrong and Aldrin's footprints in the lunar dust were not just marks of human presence, they were imprints of our collective aspiration. As they moved across the lunar surface, their every action was a blend of professionalism and wonder. They laughed, marveled, and even bounced, their movements almost playful in the moon's reduced gravity. It was a reminder that while the mission was a serious endeavor, it was also a joyous celebration of human achievement. The first steps on the moon were more than a historical milestone, they were a promise of what was to come. They were the beginning of a new chapter in human exploration, one that would inspire countless others to reach for the stars. As Armstrong and Aldrin concluded their activities and prepared to return to the lunar module, they left behind a legacy etched in the moon's surface and in the hearts of all who witnessed the moment. With the first human footprints on the moon, the Apollo 11 mission had proven that when we unite in pursuit of a common goal, the impossible becomes possible. It was a moment of unparalleled triumph, a beacon of hope, and a testament to the enduring spirit of exploration. As Armstrong and Aldrin navigated the moon's surface, their mission extended beyond the symbolic. It was a journey into the scientific unknown, a quest to unlock the secrets of our celestial neighbor. Armed with an array of tools and instruments, they embarked on a series of experiments designed to probe the moon's mysteries. One of their primary tasks was to deploy the early Apollo Scientific Experiments Package, or ESEP. This suite of instruments included a seismometer to detect moonquakes and a retroreflector to measure the distance between the Earth and Moon with unprecedented accuracy. These devices would continue to send valuable data back to Earth long after the astronauts had returned home. The seismometer was carefully placed on the lunar surface, its sensitive equipment poised to capture the slightest tremors. These measurements would reveal the moon's internal structure, offering insights into its geological activity. Meanwhile, the retroreflector, a simple yet powerful array of mirrors, would allow scientists to bounce laser beams off its surface, providing precise distance measurements and contributing to our understanding of the moon's orbit and its gradual drift away from Earth. In addition to deploying these instruments, Armstrong and Aldrin conducted soil mechanics experiments, using a penetrometer to test the moon's surface strength. This data was crucial for understanding the composition and bearing capacity of the lunar regolith, informing future missions and the potential for lunar bases. The astronauts also collected a variety of lunar samples, gathering rocks and soil from different locations and depths. Each sample was a time capsule, preserving the history of the moon's formation and evolution. These precious materials would be analyzed in laboratories around the world, revealing clues about the solar system's early days and the processes that shaped our planetary neighbors. As they meticulously gathered data and samples, Armstrong and Aldrin were acutely aware of their role as pioneers of lunar science. Their efforts laid the groundwork for decades of research, transforming the moon from a distant enigma into a wellspring of knowledge. The experiments conducted during Apollo 11 were just the beginning, setting the stage for future missions to delve even deeper into the moon's secrets. With each experiment, the astronauts bridged the gap between the known and the unknown, expanding humanity's understanding of the cosmos. Their work on the lunar surface was a testament to the power of exploration and the unquenchable thirst for knowledge that drives us to reach beyond our terrestrial boundaries. As Armstrong and Aldrin completed their scientific tasks and prepared to return to the lunar module, they left behind not only their footprints, but also a legacy of discovery. The data and samples they collected would continue to inspire and inform generations of scientists, fueling our quest to unravel the mysteries of the universe. In that brief but profound moment on the moon, the Apollo 11 mission transformed the lunar landscape into a laboratory, a place where dreams of exploration and the pursuit of knowledge converged. It was a reminder that every step we take into the unknown brings us closer to understanding the cosmos and our place within it. As Armstrong and Aldrin completed their groundbreaking work on the moon's surface, it was time to prepare for the journey home. The return to Earth was as perilous and complex as the voyage to the moon. Every step had to be executed with precision, as the lives of the astronauts and the success of the mission depended on it. The first task was to rejoin Michael Collins, who had been orbiting the moon in the command module Columbia, patiently awaiting their return. Armstrong and Aldrin ascended from the lunar surface in the lunar module Eagle, leaving behind the lower stage as a silent sentinel on the moon. The ascent stage fired perfectly, propelling them back into lunar orbit. Reuniting with Collins was a moment of triumph and relief. The three astronauts, once separated by the vastness of space, were together again, ready to begin the long journey home. The lunar module was jettisoned and the command module's engine ignited, propelling them out of lunar orbit and setting them on a trajectory back to Earth. As they traveled through the void, the astronauts had time to reflect on their historic mission. They marveled at the sight of the Earth, a brilliant blue and white marble suspended in the darkness of space. This view, so different from the stark, desolate landscape of the moon, reminded them of the fragility and beauty of their home planet. The journey was not without its challenges. The spacecraft had to be precisely oriented, and the heat shield had to withstand the intense temperatures of re-entry. The crew worked diligently, following the procedures and protocols that had been meticulously planned and practiced. As they approached Earth, the re-entry sequence began. The command module entered the Earth's atmosphere, blazing like a comet as it descended. The astronauts experienced intense G-forces, their bodies pressed against their seats. The heat shield glowed red-hot, protecting them from the searing temperatures outside. Finally, the parachutes deployed, slowing their descent. The command module splashed down in the Pacific Ocean where recovery teams were waiting. The astronauts were safe, their mission a success. They had journeyed to the moon and back, achieving what had once seemed impossible. The return journey was a testament to human ingenuity, courage, and determination. It marked the successful completion of a mission that had captivated the world and demonstrated the limitless potential of exploration. As the astronauts emerged from the command module, they were greeted as heroes, their journey a symbol of hope and inspiration for generations to come. The Apollo 11 mission had not only reached the moon, but it also returned safely to Earth, bringing with it a wealth of knowledge and a renewed sense of what humanity could achieve when we dared to dream big and reach for the stars. As the command module splashed down into the vast expanse of the Pacific Ocean, the tension of re-entry gave way to a wave of relief and celebration. The astronauts had endured the fiery descent through Earth's atmosphere, and now the final phase of their historic journey was at hand. The recovery teams stationed aboard the USS Hornet sprang into action. Helicopters took off, slicing through the air with a sense of urgency and purpose. Their mission to safely retrieve the heroes who had ventured farther than any human before. The command module bobbed gently on the ocean's surface, its heat shield scorched but intact, a testament to the engineering marvels that had protected its precious cargo. As the helicopters approached, divers plunged into the water, securing flotation devices around the spacecraft to ensure its stability. With the command module stabilized, the hatch was opened, and the astronauts were greeted by the fresh sea air and the beaming faces of the recovery team. One by one, Armstrong, Aldrin, and Collins were carefully hoisted into the helicopters, their journey through space now complete. Back on the USS Hornet, a quarantine area had been prepared. Although the risk of lunar pathogens was deemed minimal, NASA took no chances. The astronauts would spend several days in isolation, undergoing medical examinations to ensure their health and safety. As they were flown to the aircraft carrier, the world watched in awe and admiration. The splashdown and recovery were broadcast live, a fitting conclusion to a mission that had captivated millions. When the helicopters landed on the deck of the USS Hornet, the astronauts were met with cheers and applause, a hero's welcome. In the days that followed, the astronauts reflected on their journey, sharing their experiences and insights with the world. The successful splashdown and recovery marked the end of one chapter and the beginning of another, as humanity looked to the stars with renewed hope and ambition. The Apollo 11 mission had not only achieved its goal of landing on the moon, but it also demonstrated the power of human ingenuity, courage, and collaboration. The safe return of Armstrong, Aldrin, and Collins was a testament to the skill and dedication of countless individuals who had worked tirelessly to make the dream of lunar exploration a reality. And as the astronauts emerged from quarantine, they carried with them the spirit of adventure and the promise of future discoveries, inspiring generations to come to reach for the stars. The Apollo missions left an indelible mark on science and technology, ushering in a new era of innovation and discovery. Beyond their historic achievements, these missions catalyzed advancements that transformed our understanding of the universe and our place within it. The data collected from lunar samples revolutionized planetary science. Geologists and astronomers gained insights into the moon's formation and evolution, shedding light on the early history of our solar system. This wealth of information continues to inform scientific research, revealing new mysteries and guiding future explorations. Technologically, the Apollo program spurred the development of cutting-edge technologies that have since permeated everyday life. The need for compact, reliable systems led to advancements in computing, telecommunications, and materials science. Innovations such as integrated circuits and new materials found applications far beyond space exploration, driving progress in various industries. Medical science also benefited from the rigorous health monitoring and life support systems developed for astronauts. Techniques and technologies initially designed for space travel have been adapted for use in medical diagnostics, patient monitoring, and emergency response, improving healthcare outcomes on Earth. The collaborative spirit of the Apollo program fostered international partnerships and inspired a global community of scientists and engineers. The lessons learned from Apollo have informed subsequent space missions, from the Space Shuttle to the International Space Station and beyond. The program's legacy continues to shape the future of space exploration as humanity sets its sights on Mars and other distant worlds. In essence, the Apollo missions were more than just a journey to the moon. They were a giant leap for science and technology. They demonstrated the power of human ingenuity and the boundless potential of collaborative effort. As we continue to explore the cosmos, the impact of Apollo serves as a beacon, guiding our quest for knowledge and inspiring future generations to reach for the stars. The legacy of the Apollo missions extends far beyond the boundaries of space exploration. They embody the triumph of human spirit, curiosity, and determination. These missions not only achieved the unimaginable, but also inspired generations to dream big and push the limits of what is possible. The Apollo missions ignited a passion for science, technology, engineering, and mathematics, STEM, across the globe. Educational programs flourished, and a new wave of scientists and engineers emerged, driven by the wonder of space and the desire to explore the unknown. The iconic image of astronauts walking on the moon became a symbol of human achievement, a testament to what can be accomplished through innovation and teamwork. Politically, the Apollo program demonstrated the power of peaceful competition, and international collaboration. It showed the world that space exploration could unite nations in a common goal, fostering goodwill and cooperation. The technology and knowledge gained from Apollo laid the groundwork for future international partnerships, such as the International Space Station, where astronauts from different countries work together in the pursuit of scientific discovery. Culturally, Apollo has left an indelible mark on art, literature, and media. Films, books, and art inspired by the missions have captured the imagination of millions, keeping the spirit of exploration alive. The phrase, "one small step for man, one giant leap for mankind," has become a timeless expression of human progress and aspiration. In the decades since the last Apollo mission, the program's legacy continues to influence modern space exploration. The Artemis program, aiming to return humans to the moon and eventually send astronauts to Mars, builds upon the foundation laid by Apollo. The lessons learned, the technologies developed, and the spirit of exploration that Apollo instilled are guiding humanity towards a new era of space travel. In essence, the legacy of Apollo is a legacy of hope, ambition, and the unwavering belief that we can reach beyond our current limitations. It reminds us that with courage, innovation, and unity, the stars are within our grasp. As we look to the future, the horizon of space exploration extends far beyond our moon. The achievements of the Apollo missions laid the foundation for a new era, one where humanity's reach will stretch across the solar system and beyond. With advancements in technology and international collaboration, the dream of exploring Mars is closer than ever. Space agencies around the world, including NASA, ESA, Roscosmos, and CNSA, are developing missions that will not only land humans on Mars but establish sustainable colonies. These endeavors will require unprecedented innovation in life support systems, propulsion technology, and habitat construction. Private companies like SpaceX and Blue Origin are also playing a crucial role, driving competition and accelerating progress. The Artemis program, a successor to Apollo, aims to return astronauts to the moon by the mid-2020s, creating a lunar gateway that will serve as a staging point for deeper space missions. This gateway will enable longer stays on the lunar surface, allowing scientists to conduct extensive research and prepare for the challenges of Mars. Beyond Mars, the exploration of the outer planets and their moons holds tantalizing possibilities. Europa, one of Jupiter's moons, and Enceladus, orbiting Saturn, are prime candidates in the search for extraterrestrial life due to their subsurface oceans. Missions to these distant worlds will push the boundaries of our engineering capabilities and scientific understanding. In addition to planetary exploration, the development of space tourism and commercial spaceflight is transforming our relationship with space. Companies are working on making space travel accessible to civilians, creating opportunities for people to experience the wonders of space firsthand. Moreover, the advancement of telescopes and space observatories will continue to reveal the secrets of the cosmos, from the formation of stars and galaxies to the enigmatic phenomena like black holes and dark matter. These discoveries will deepen our understanding of the universe and our place within it. The future of space exploration is a testament to human ingenuity and the unyielding desire to explore the unknown. As we stand on the cusp of this new frontier, we are reminded of the words of Carl Sagan, who said, "Somewhere, something incredible is waiting to be known." With each mission, each discovery, we take another step toward unveiling the mysteries of the cosmos and securing our place among the stars. Gap 2S. As we continue to explore the vast expanse of space, it becomes increasingly clear that no single nation can achieve these monumental goals alone. The spirit of international cooperation is more vital than ever, fostering unity and shared ambition among nations. Gap 2S. One of the most significant examples of this collaboration is the International Space Station, ISS, a beacon of human ingenuity and partnership. Launched in 1998, the ISS is a joint effort by NASA, Roscosmos, JAXA, ESA, and CSA, bringing together astronauts, scientists, and engineers from around the globe. This floating laboratory has become a hub for scientific research, technological development, and international camaraderie, demonstrating what humanity can achieve when working together. Gap 2S. Looking ahead, the Artemis Accords, spearheaded by NASA, represent another step toward global cooperation. These agreements outline principles for peaceful and transparent exploration of the moon and beyond, inviting countries to contribute their unique expertise and resources. The goal is to create a sustainable and cooperative presence on the lunar surface with the vision of advancing to Mars and other celestial bodies. GAP2S. The European Space Agency, ESA, and Roscosmos are partnering on the ExoMars mission, aiming to search for signs of past life on the Red Planet. Meanwhile, China's CNSA has launched the Chang'e lunar missions and the Tianwen Mars missions, contributing valuable data and fostering a spirit of shared discovery. GAP2S. Private companies are also playing a crucial role in this global effort. SpaceX's Crew Dragon and Boeing's Starliner have opened new avenues for international astronauts to travel to the ISS. This democratization of space travel is paving the way for more inclusive exploration, allowing smaller nations to participate in space missions. GAP2S. As we venture further into the cosmos, the importance of international collaboration cannot be overstated. The challenges we face are immense, but by pooling our knowledge, resources, and aspirations, we can overcome them. Together, we will unlock the mysteries of the universe and ensure that the exploration of space remains a shared endeavor for the benefit of all humankind. GAP2S. The journey to the stars is a collective one, and the partnerships we forge today will light the way for generations to come. As we look up at the night sky, we are reminded that our greatest achievements are those we accomplish together. GAP2S. As the quest for space exploration continues, a new era is dawning, driven by the innovative spirit of private companies. These ventures are not only complementing governmental space agencies but also propelling humanity toward new frontiers with unprecedented speed and efficiency. GAP2S. One of the most prominent players in this arena is SpaceX, founded by Elon Musk. With its groundbreaking launch vehicles like the Falcon 9 and the Falcon Heavy, SpaceX has revolutionized space travel by making reusable rockets a reality. The Crew Dragon spacecraft has successfully ferried astronauts to the International Space Station, marking a new chapter in human spaceflight. GAP2S Blue Origin, led by Amazon's Jeff Bezos, aims to make space accessible to everyone. With the New Shepard suborbital rocket and the upcoming New Glenn orbital launch vehicle, Blue Origin is developing the infrastructure needed for a future where millions of people can live and work in space. Their vision extends to lunar exploration with the Blue Moon lander, designed to support NASA's Artemis program. GAP2S. Virgin Galactic, founded by Sir Richard Branson, is pioneering space tourism. With its Spaceship Two spacecraft, Virgin Galactic is on the cusp of making suborbital space flights a reality for private citizens, opening the door to a new industry of space tourism and research. GAP2S. In addition to these giants, numerous other private companies are making significant strides. Rocket Lab, with its Electron rocket, is providing frequent and cost-effective access to space for small satellites. Sierra Nevada Corporation's Dream Chaser spacecraft is set to deliver cargo to the ISS, and companies like Astrobotic and Intuitive Machines are developing lunar landers for commercial payloads. GAP2S. The rise of these private ventures is democratizing space exploration, making it more accessible and affordable. They are fostering a competitive environment that accelerates technological advancements and reduces costs, benefiting both governmental agencies and the broader scientific community. GAP2S. As we look to the future, the collaboration between public and private sectors will be crucial. These partnerships will enable more ambitious missions, from lunar bases to Mars colonization and beyond. The combined efforts of private innovation and public vision will unlock new possibilities, ensuring that the dream of space exploration remains vibrant and achievable for generations to come. GAP2S. As humanity sets its sights on more distant destinations, the challenges of long-duration space missions come into sharp focus. Venturing beyond the relative proximity of the Moon to places like Mars or even deeper into our solar system presents a myriad of obstacles that must be overcome. GAP2S. One of the most significant challenges is the human factor. Prolonged exposure to microgravity can lead to muscle atrophy, bone density loss, and fluid shifts that affect vision and other bodily functions. Astronauts must engage in rigorous exercise regimens and medical monitoring to mitigate these effects. GAP2S. Psychological challenges are also paramount. The isolation and confinement of space travel, coupled with the distance from Earth, can lead to mental health issues. Ensuring the well-being of astronauts requires comprehensive support systems, including communication with loved ones, entertainment, and mental health resources. Gap 2S. Radiation exposure is another critical concern. Unlike the relatively protected environment of low Earth orbit, deep space missions expose astronauts to higher levels of cosmic radiation and solar particle events. Advanced shielding technologies and potential medical countermeasures are being researched to safeguard crews. Gap 2S. Life support systems must be robust and reliable, capable of recycling air, water, and waste for extended periods. The development of closed-loop systems is essential to sustain long-duration missions without constant resupply from Earth. Gap 2S. The vast distances involved also pose logistical challenges. Communication delays can range from several minutes to over half an hour, complicating real-time decision-making and requiring greater autonomy for astronauts and onboard systems. Gap 2S. Technological advancements in propulsion are necessary to reduce travel time and make these missions viable. Current propulsion methods are too slow for practical human missions to Mars and beyond. Concepts like nuclear thermal propulsion and advanced electric propulsion are being explored to shorten journey times and improve mission feasibility. Gap 2S. Despite these formidable challenges, the pursuit of long-duration space missions continues to drive innovation. The lessons learned from these endeavors will not only pave the way for human exploration of Mars and beyond, but also enhance our understanding of living and working in space, benefiting life on Earth and inspiring future generations of explorers. Gap 3S. As humanity reaches farther into the cosmos, one of the most profound questions we seek to answer is whether we are alone in the universe. The search for extraterrestrial life has captivated the imaginations of scientists and dreamers alike, driving us to explore the unknown depths of space. Gap 2S. This quest begins with the study of our own solar system. Mars, with its history of liquid water and potential subsurface reservoirs, stands as a prime candidate for harboring microbial life. Missions like the Mars rovers and the upcoming Mars Sample Return aim to uncover signs of past or present life on the red planet. Gap 2S. Beyond Mars, the icy moons of Jupiter and Saturn, such as Europa and Enceladus, hold tantalizing possibilities. Beneath their frozen crusts lie vast oceans of liquid water kept warm by tidal forces. These subsurface oceans could provide the necessary conditions for life to thrive, and missions like the Europa Clipper and future landers are poised to investigate these alien seas. Gap 2S. The search extends beyond our solar system to the exoplanets orbiting distant stars. The Kepler Space Telescope and its successor TESS have identified thousands of these distant worlds, some of which reside in the habitable zone where liquid water could exist. The James Webb Space Telescope, with its advanced capabilities, will soon allow us to study the atmospheres of these exoplanets, searching for biosignatures that may indicate the presence of life. Gap 2S. The search for extraterrestrial intelligence, or SETI, takes a different approach, listening for signals from advanced civilizations. Radio telescopes around the world scan the skies, hoping to detect a message from another intelligent species. While no definitive signals have been found yet, the search continues, driven by the hope that we are not alone. Gap 2S. The discovery of extraterrestrial life, whether microbial or intelligent, would be one of the most significant milestones in human history. It would reshape our understanding of life and our place in the universe, opening new avenues of scientific inquiry and philosophical reflection. Gap 2S. As we continue to explore the cosmos, the search for extraterrestrial life remains a beacon of curiosity and wonder, inspiring us to look beyond our world and imagine the possibilities that lie among the stars. Gap 3S. As we extend our reach into the cosmos, the dream of human settlement on other planets transforms from science fiction into a tangible goal. This vision, fueled by the advancements in space technology and the enduring spirit of exploration, holds the promise of a multiplanetary future for humanity. Gap 2S. Mars stands at the forefront of this ambition. With its relatively similar day-length seasons and the presence of water in the form of ice, Mars is considered the most viable candidate for human colonization. Plans for Mars habitats envision self-sustaining colonies utilizing local resources for water, oxygen, and building materials. The challenges are immense, from radiation exposure to the psychological effects of long-duration isolation. But ongoing research and missions like SpaceX's Starship aim to overcome these hurdles. GAP-2S. Beyond Mars, the moons of the gas giants offer intriguing possibilities. Titan, Saturn's largest moon, has a thick atmosphere and lakes of liquid methane, presenting unique opportunities and challenges for human habitation. Advanced robotic missions and future crewed expeditions could pave the way for establishing outposts on these distant worlds. GAP-2S. The concept of space habitats, such as rotating space stations or O'Neill cylinders, also presents a compelling vision for off-world living. These massive structures, envisioned to house thousands of people, could orbit planets or exist in the vastness of space, providing artificial gravity and a controlled environment for human life. GAP-2S. The journey to becoming a multiplanetary species will require unprecedented collaboration, innovation, and resilience. It will demand advancements in life support systems, propulsion technologies, and sustainable living practices. Yet the potential rewards are boundless, ensuring the survival of our species, expanding our horizons, and inspiring generations to come. GAP-2S. As we stand on the precipice of interplanetary exploration, the dream of human settlement on other planets ignites our imagination and propels us toward a future where humanity's footprint extends beyond Earth into the vast expanse of the cosmos. GAP-3S. As humanity prepares for the next giant leap into the cosmos, the development of groundbreaking technologies becomes paramount. These innovations are not just about reaching new destinations, but ensuring the safety, sustainability, and success of long-duration space missions. GAP-2S. One of the critical areas of advancement is propulsion technology. Traditional chemical rockets, while powerful, have limitations in terms of efficiency and speed. New propulsion systems, such as ion thrusters, nuclear thermal propulsion, and even the theoretical concept of a warp drive, promise to revolutionize space travel, making interplanetary journeys faster and more feasible. GAP-2S. Life support systems are another crucial frontier. Future missions will require closed-loop systems capable of recycling air, water, and waste to support human life for extended periods. Innovations in bioregenerative life support, which use plants and microorganisms to regenerate vital resources, are being explored to create self-sustaining habitats both in space and on other planets. GAP-2S. Radiation protection remains a significant challenge for deep space missions. Advanced shielding materials, magnetic deflection systems, and pharmaceutical countermeasures are under development to protect astronauts from the harmful effects of cosmic radiation. These technologies will be essential for missions to Mars and beyond, where radiation levels are much higher than in low Earth orbit. GAP-2S, autonomous systems and artificial intelligence will play a pivotal role in future space missions. From navigation and landing systems to habitat maintenance and scientific research, AI-driven technologies will enhance the capabilities of human explorers, allowing for greater efficiency and safety in the harsh environments of space. GAP-2S. In situ resource utilization, or ISRU, is another game-changing technology. By harvesting and utilizing local resources such as water ice on Mars or lunar regolith, future missions can reduce the need for supplies from Earth, making long-term habitation more viable. This approach not only lowers costs but also paves the way for sustainable off-world colonies. GAP-2S. As we continue to push the boundaries of space exploration, the development and implementation of these technological innovations will be crucial. They will not only enable us to reach new worlds, but also ensure that humanity can thrive in the vast expanse of the cosmos, turning the dreams of today into the realities of tomorrow. GAP-3S. Space exploration is more than just a quest for knowledge or a display of technological prowess. It is a vital endeavor for the future of humanity. As we look toward the stars, we are not only searching for answers about our place in the universe, but also ensuring the survival and prosperity of our species. GAP-2S. One of the most compelling reasons for space exploration is the pursuit of knowledge. By studying other planets, moons, and celestial bodies, we gain insights into the origins and evolution of our own planet. These discoveries have the potential to unlock answers to fundamental questions about the formation of the solar system, the conditions necessary for life, and the potential for life beyond Earth. GAP-2S. Space exploration also drives technological innovation. The challenges of operating in the harsh environment of space have led to the development of new materials, advanced robotics, and cutting-edge medical technologies. These innovations often find applications here on Earth, benefiting industries ranging from healthcare to telecommunications and beyond. Gap 2S. The search for extraterrestrial life is another profound aspect of space exploration. Finding evidence of life elsewhere in the universe would fundamentally change our understanding of biology, evolution, and our place in the cosmos. It would also have profound philosophical and ethical implications, prompting us to reconsider our responsibilities as stewards of our own planet. Gap 2S. Space exploration fosters international collaboration and unity. The vastness of space and the complexity of space missions necessitate cooperation among nations. Programs like the International Space Station have shown that, despite geopolitical differences, countries can work together towards common goals, promoting peace and understanding on a global scale. Gap 2S. Finally, space exploration serves as an inspiration for future generations. The stories of astronauts, the images of distant worlds, and the achievements of space missions ignite the imaginations of young people, encouraging them to pursue careers in science, technology, engineering, and mathematics. This inspiration is essential for nurturing the next generation of innovators, problem solvers, and explorers. Gap 2S. As we continue to venture into the cosmos, we must remember that space exploration is not just about reaching new destinations. It is about pushing the boundaries of human potential, fostering global cooperation, and ensuring the long-term survival and prosperity of humanity. The journey to the stars is a journey for all of us, and its importance cannot be overstated. The Apollo program consisted of 11 crewed missions, each building upon the successes and lessons learned from its predecessors. These missions tested spacecraft, trained astronauts, and conducted scientific experiments in preparation for the ultimate goal of a lunar landing. Apollo 8 in 1968 was the first crewed mission to orbit the Moon, capturing stunning images of the Earth rising above the lunar horizon. Apollo 9 and 10 further tested the lunar module in Earth and lunar orbit, respectively. These missions paved the way for Apollo 11, the mission that would forever etch its place in history. On July 20, 1969, the world held its breath as Neil Armstrong, Buzz Aldrin, and Michael Collins embarked on humanity's first mission to land on the Moon. Millions watched on television as the lunar module Eagle touched down on the Sea of Tranquility. Neil Armstrong's words, "That's one small step for a man, one giant leap for mankind," became etched in history. He and Aldrin spent hours on the lunar surface, collecting samples, conducting experiments, and planting the American flag. The crew of Apollo 11 returned to Earth as heroes, having achieved what was once thought impossible. Their mission marked a pivotal moment in human history, a testament to our boundless ambition and ingenuity. Section 5. Innovations for the Cosmos. The Apollo missions were a technological marvel, driving innovation and advancements in various fields. The need to design and build spacecraft capable of withstanding the harsh conditions of space led to the development of new materials, propulsion systems, and communication technologies. The Saturn V rocket, the most powerful rocket ever built, was designed specifically for the Apollo missions. It stood over 360 feet tall and could generate over 7.5 million pounds of thrust, propelling the Apollo spacecraft to the Moon. The Apollo missions also spurred advancements in computer technology, miniaturization, and software development. The guidance systems, navigation tools, and life support equipment developed for Apollo had a profound impact on various industries. Section 6. Overcoming the unknown. The journey to the Moon was not without its challenges and setbacks. The Apollo program faced numerous technical difficulties, equipment failures, and even a near-fatal fire during a pre-launch test for Apollo 1. However, these challenges were met with unwavering determination and a commitment to safety. Engineers and scientists worked tirelessly to overcome obstacles, learning from each setback and improving upon designs. The Apollo 13 mission, which experienced a critical oxygen tank explosion on its way to the Moon, demonstrated the ingenuity and resilience of the Apollo team. Through creative problem-solving and teamwork, they were able to bring the crew back safely to Earth.
Check, check. Check 1, check 2, check, check.
Section 7, a legacy etched in stars. The Apollo missions left an enduring legacy, shaping our understanding of the Moon, Earth, and our place in the cosmos. The lunar samples brought back provided valuable insights into the Moon's composition, history, and formation. The missions also gave us a new perspective on our own planet. Images of Earth from space, such as the iconic blue marble photograph, highlighted its beauty, fragility, and the interconnectedness of all life. The Apollo program ignited a passion for science and engineering, inspiring generations to pursue careers in STEM fields. It demonstrated the power of human collaboration, innovation, and the pursuit of knowledge. Section 8, Inspiring Future Explorers. The spirit of Apollo continues to inspire us today, fueling our dreams of further exploration and discovery. The lessons learned from Apollo, both technical and inspirational, serve as a foundation for future missions to the Moon, Mars, and beyond. Private companies and international space agencies are now collaborating on ambitious projects, pushing the boundaries of space exploration even further. The International Space Station stands as a testament to the power of international cooperation in space. The Apollo missions taught us that anything is possible when we set our minds to it. They remind us that the human spirit of exploration and discovery knows no bounds. Section 9, Beyond the Horizon. As we look to the future, the legacy of Apollo reminds us that our journey into the cosmos is far from over. New discoveries await us, new challenges will arise, and new generations will be inspired to reach for the stars. The spirit of exploration that fueled the Apollo missions continues to burn brightly within us. It is a reminder that we are capable of achieving great things when we work together towards a common goal. Let us continue to explore, to discover, and to push the boundaries of human knowledge. For in the vast expanse of space, there is still so much more to learn and explore.